This is section 1.4 in pre-calculus. So this is kind of all things parabolas that you would have looked at in Algebra 2. So this was a big topic in Algebra 2, and it's pretty big in pre-calculus, but we're going to try and kind of simplify it down to the basics. So the first thing that we're going to talk about is graphing parabolas that are in vertex form. Now, keep in mind, I'm showing you here what vertex form looks like. And let me give you an example that might have numbers. So this parabola might be y equals, maybe where the a is, there's a 2, and this might be x minus 3 that's being squared, plus, I'll just say 1. So remember, the idea that it's being squared is what makes it a parabola, right? The fact that you have an x squared, that's what makes it a parabola. And all the other numbers are what adjust the parabola. So one thing that we would talk about, and I'm going to kind of go back and forth, what we talk about is the basic parent function. We've already mentioned this, is the parabola. That's vertex right there at 0, 0. And you could kind of mark off a point up 1 over 1 on both sides just to kind of help you be accurate. And then you would just kind of draw your shape of your parabola. Well, notice what I have here. What I've changed is the number in front, a 2 versus a negative 2. So that means we're talking about this a number. So keep in mind, if the a is positive, you know the parabola opens up. If the a is negative, you know the parabola opens down. And we could say the higher the a value, the more narrow the parabola. But one thing that we tend to talk about is kind of this concept of slope. And we always kind of put it in air quotes because it's not really slope. But notice if there's a 1 in front, that's why we went up 1 over 1 on each side. But the reason we put it in air quotes is because you can't keep doing that. If you keep going up 1 over 1, if you were to keep going up 1 over 1, then that's going to be a straight line. It's not going to be a parabola. So the concept of slope only works for 1 unit away from the vertex. So on this one, we would say, well, it's the basic parabola at the origin, but I'm going to go up 2 and over 1. So that means this parabola should look a little bit more narrow than the last one. Or like if it's a negative 2, that means you're going down 2 over 1. So you can see the parabola is opening down. So it's not only is it kind of narrow, but it's opening down. Okay, so then the next thing we talk about is, well, what if there's a number in the, let's see, which one do we talk about next here? We'll come back to that next. Okay, what if there's a number in the parentheses, right? So remember, in the parentheses, that's what moves it left or right. We call it a horizontal shift. So if it's a plus, it's kind of the opposite of what you would think. It actually shifts the parabola to the left. And if it's a minus, it actually shifts the parabola to the right. So let's look at letter G. So I've got my basic parabola at the origin, but then I shift it 2 units to the left. But notice the 1 out in front, so it's still in kind of an up 1 over 1, and then I draw my basic shape. Okay, because it's a minus 1, this one's going to go to the right 1. I still have that slope concept up here of the 2, so it's going to be a little bit more narrow opening up. Okay, the plus 1 moves it to the left, slope negative 2. Again, you can't see me when I say the word slope, but I'm not really meaning that it's a slope. Okay, so that was the number on the inside. And then we need to talk about what if there's a number on the outside, right? Like this plus k. All right, so remember the number on the outside is a vertical shift. So it's a plus, it shifts it up. If it's a minus, it shifts it down. So let's look at letter G. So I've got my basic parabola. So from the origin, I'm going to go 2 to the right, and then that plus 1 at the end means up 1. So that's where my new vertex is. Then I take into account that slope idea, and I draw my graph. So you're kind of doing all of this at once. Okay, so on this one, the plus 1 is going to be left 1. The minus 2 is down 2. Now on this one, the slope idea is 1/3. So fractions make it wider. But you don't mark off like up 1 over 3. It doesn't work that way. Remember, the idea of slope only works 1 unit away from the vertex. So you need to think of this as kind of like being 1/3 over 1. So you go up 1/3 and over 1. You go up 1/3 and over 1. And then, so put the points on, but then do me a favor and kind of exaggerate it so I can tell that you know this parabola is opening wide. Okay? On this one, there's no parentheses, so it doesn't shift left or right. This one only shifts up 3 with the slope idea of -2. Now, I know I'm going through this stuff fast, but that's because you should really remember this very well. Like you shouldn't even really need me saying much of anything here. Okay, so that's our vertex form. And then we talked about parabolas in standard form. Now, I personally think the least valuable as far as what you'll use, in later math kind of thing is standard form. But there are a couple things to mention, especially because they could come up in standardized tests. So the idea about standard form, that means you don't have any parentheses squared, but everything's all multiplied out. Like it might be an example of y equals 2x squared plus 3x plus 4. That would be standard form. But we know it's still a parabola because of the x squared. It's just harder to tell where the origin is, or if it's shifted up or down or left or right or what. Okay? So what we talk about is the axis of symmetry is always going to be x equals -b over 2a. And the axis of symmetry, remember how when you have a parabola, I'll say right here, the axis of symmetry is kind of that invisible line that goes right down through the middle of the parabola. And we call it an axis of symmetry because the part of the parabola on the right is a mirror image of the part of the parabola on the left. So we call it the axis of symmetry. It always goes down through the vertex. Well, since it goes through the vertex, that means that the x-coordinate of the vertex is whatever the axis of symmetry is. So the x-coordinate is whatever that number is. And then in order to find the y-coordinate, you're going to substitute into the equation. Okay? Let me show you what I mean by that. So let's say I look here at number 1. That's what I want to look at. Don't I have any examples of this? Yeah, we'll look at it on number 1. I know, so for now I'm ignoring these directions. We'll pretend like this only goes to this one. Okay, so the axis of symmetry is going to be x equals, so the b number is -2, so the formula says -b. So I'm going to say +2 over the a number is 1. So the axis of symmetry is x equals 2. So right here is the kind of the imaginary line that's going down through the middle of the parabola. So that means the vertex has that x number, 2 comma something. So in order to figure out what the y value is, I'm going to substitute that 2 in everywhere I see an x. So 2 squared minus 2 times 2 plus 2. So in this situation, the y-coordinate happens to be a 2 also, just a coincidence. So that's how I know the vertex is right here. Okay, so in this case, there's one other thing that standard form would tell me, and that is the y-intercept. And this is probably, I think, the most beautiful thing about standard form, because the y-intercept is always just the c number. If I'm writing it as an ordered pair, it's going to be 0, comma, c. So if I look down here at the one I'm talking about, so if this is my vertex, then I know that my y-intercept is going to be the point 0, comma, the c number right here is 2. Sorry, look what I did. Sorry about that. I made a mistake on my formula. I hope you saw it. Again, live, being in class never replaces a video. But so remember, the formula was -b over 2a. I did just -b over a. So if it were over 2a, then actually my axis of symmetry is 2 over 2, which is 1. Sorry about that. Let's fix it. Axis of symmetry is at 1. And that means that my vertex has an x-coordinate of 1 comma something. So in order to find out what the y value is, plug your 1 into your equation. So 1 squared minus 2 times 1 plus 2. I think that's going to come out to be 1, isn't it? So 1, 1 is my vertex. Okay, and then the y-intercept is that C number. Well, the C number is 2, so my y-intercept is 0, 2, which is right here. And the thing about the axis of symmetry, because I know that the left side of that axis is the same as the right side, so that tells me that there's also a point mirrored on this side right there, and I can draw my parabola. So in this case, I just used standard form. Okay. Now let's talk about changing an equation into vertex form. All right. Okay. So now let's talk about the idea of if I have it in vertex form, if I have my equation in vertex form, then I can go straight to the graph. So instead of maybe messing with this standard form, it might be easier to take my equation and turn it into vertex form. In other words, I want to turn it into looking like, generically speaking, I want to turn it into looking like y equals some parenthesis squared. Now, yeah, there might be some number out in front, and there might be some number, added or subtracted out here at the end, but that's what vertex form generally looks like. You have a parenthesis squared, okay? Now, I think instead of like writing out these steps, because it can almost look too tedious when you write out the steps, I think what I'm just going to do is just talk you through the way we would have done it in the past. And actually, I think it will be helpful to start with this basic one over here. I didn't really intend to do this one using standard form. I just wanted to kind of show you what my explanation was at the top. But I'm going to leave the parabola. I'm just going to take off this work. And in fact, we'll just put it in vertex form, and we'll see if it actually matches the parabola. Okay, so vertex form means instead of x squared minus 2x plus 2, I want this to look like some parenthesis squared. Okay, so I know this is going to be an x. I always know that the sign in there is going to match this sign, so I'm going to bring down the minus. And I bet you remember even this, that if the number on the x here, whatever that number is, you take half of it to put into your parenthesis. Okay, now here's the thing. By writing it that way, I've really changed the value of this equation. Like x squared minus 2x plus 2 does not equal x minus 1 squared. If I were to square it out, yes, I would have the x squared and the minus 2x. That would be the same. But what would be different is the last number right here. If this were squared out, that last number would be 1 squared. It would be a plus 1. So by writing it this way, I've really changed the equation. Well, we don't want to change the equation. We want it to be equivalent. We just want to change the form. So here's the idea. If right now it's a plus 1, then what could I put over here at the end to turn that 1 back into a 2? Well, couldn't I just put a plus 1? Because if I add 1 to the existing 1, wouldn't it be a 2? So what that means is the vertex form is this. Well, does that match the parabola that we did down below? In other words, is this a parabola that's moved 1 unit to the right and 1 unit up? Well, it sure does, doesn't it? Okay, look at number 2. So I know what I want to turn this into. Notice I'm leaving a space for a second here. I know I want to turn it into a parenthesis squared, maybe a number at the end, maybe not. All right, so here's the problem with this one. You can't go straight to completing the square if you have a number out in front. You have to factor that number out first. No matter what that number is, you have to first factor that number out. So first, I'm going to factor out of the 2. It's going to leave me with an x squared minus 6x. And this is going to seem strange, but we're only going to factor it out of the x's. I'm going to leave the plus 16. And you might be saying, oh, you have to do it all the way across. No, you don't. If you want it in factored form, you have to. But I don't care about this being in factored form. I'm trying to manipulate it into vertex form. That's not factored form. Okay? So now I'm ready to complete the square. So I'm going to keep that 2 out in front. I use this x squared minus 6x. I know it's going to be an x. Remember, whatever this sign is comes straight down. and then I'm going to take half of this number. So this is going to be a 3. All right, so now let's think it through. I've changed the equation by writing it this way. Okay, so here's the deal. If I were to multiply this out, yes, I'm going to have the x squared and the minus 6x. But then the last number, once this is multiplied out, the last number is going to be 3 squared. So that's going to be a 9. And even though it's a negative 3, when it's squared, it's a positive 9. So it's always going to be a positive. But once that's all squared out, then I would distribute that 2, right? So really that last number is 18, isn't it? But I don't want it to be 18. What did it have up there originally? Originally, it had a 16. So how am I going to turn that 18 back into a 16? Or what can I do to the 18 to bring it down to 16? Well, I could just subtract 2. So that is my vertex form. If I'm going to graph it, which I don't really care about that much right now, I would go 3 to the right, 2 down, mark off my slope of 2, and there's my parabola. Okay? Because this is probably the more, I don't know, difficult or confusing or less familiar form, I'm going to go ahead and do a couple more that have negatives. Okay, so we follow the same pattern. Remember, you can't complete the square if you have a number in front of your x squared. So the first thing I need to do is factor out that negative 4. It's going to leave me with x squared plus 4x, and then leave the minus 12. Okay, now I'm ready to complete the square. So leave the negative 4. This is going to become an x plus 2 quantity squared. So now I have to think it through. That 2 squared is 4. That's being multiplied by the negative 4. So really I'm at negative 16. I don't want negative 16. I want negative 12. So to bring that back up to negative 12, I'm going to need to put here a plus 4. Negative 16 plus 4 will bring it back to negative 12. So this is my vertex form. So left 2, up 4, slope of negative 4. I'm going to have this skinny little parabola. Okay, my parabola's not looking great. Sorry. Opening down. Okay, let's look at this one. Factor out your negative 3. It's going to leave me with, it's going to be a minus, right? Because I'm taking out the negative. Minus 2x. And then I'm ready to complete the square. So half of 2. Okay, let's think it through. If I have 1 squared times negative 3, and then to bring it back up to negative 2, I'm going to need to add 1. So there is my vertex form. So right 1, up 1, slope of negative 3. Slope in air quotes, right? Okay. And then the last form I want to talk about is factored form. And I don't know why we don't talk about this one that much in a lot of Algebra 2 classes, because I personally think it is definitely a valuable form. In fact, we'll use it on things other than parabolas as well. Okay, so the beauty of factored form is when it's in factored form, it tells you the zeros. So let's just put that down here. Factored form automatically will show you the zeros of the parabola. And what is another name for parabola? Did I spell it right? What's another name for the zeros? Well, the x-intercepts. Okay, so I've got my factored form. Number 1, how do you know the graph will be a parabola? Well, because if it were multiplied out, if you were to do the FOIL, wouldn't you get an x squared term? Right? And if there's an x squared term, you know it's a parabola. Okay, does the parabola open up or down? Well, again, if you multiply this out, wouldn't that x squared at the beginning be a positive? I'm going to do this. I'm going to say it opens up because I know that's going to be a positive x squared. Okay, what are the zeros? So here's the beauty of it. Remember, the zeros come from what would make each of those factors equal to 0. Well, if x plus 2 equals 0, then I'm going to get negative 2. And if x minus 4 equals 0, I'm going to get positive 4. So my zeros are negative 2 and positive 4. Okay. And the good thing about this is we know that the axis of symmetry is going to be right in the middle of those two numbers. Well, if I'm from negative 2 to 4, wouldn't the middle be right here at 1. So this is the axis of symmetry. It's always the middle. So x equals 1. And remember, the axis of symmetry always goes through the vertex. So that's how you know the vertex is 1 comma something. Well, how do I know what the y value is? Well, what do we do on standard form? Didn't we plug this in? Well, if I plug in a 1 up here in place of every x, in the first parenthesis, I'm going to get 3, 1 plus 2. In the second parenthesis, I'm going to get negative 3. So wouldn't the y value be negative 9? So on the axis of symmetry, down at negative 9 is where I'm going to have my vertex. I lost track. 1, 2, 3, 4, 5, right here. And I've got enough to draw my parabola, right? I have 3 points here. I could draw my parabola something like this. Okay? So the beauty of factored form is that, yes, it first of all gives you the zeros, and then from the zeros, that can lead you to the axis of symmetry and the vertex. Okay, so here we are in factored form. So the zeros are going to be what makes each of those equal 0. So it would be at negative 1/2 for the first parenthesis and at positive 1/2 for the second parenthesis. And just estimate where 1/2 is. So negative 1/2 and positive 1/2. Okay, remember the axis of symmetry is going to be in the middle. Well, the middle of negative 1/2 and positive 1/2 is going to be 0, which means the vertex is going to be 0 comma something. If I plug 0 in for each of these x's, I'm going to get 1 times negative 1 is negative 1. So right here. So my parabola does something like this. Okay. This is a good critical thinking question related to parabolas. Okay, so notice it says use the graph of f of x equals, okay, so this is the standard form equation. Now, it's saying I don't know what a, b, and c are. I mean, there's some numbers, I just don't know what they are, okay? But what I do know, when you look at the picture, I can tell that the zeros are at negative 2 and 6, okay? So true or false, is the axis of symmetry at positive 2? Well, we know the axis of symmetry is the middle, so I need to think about, well, where is the middle? Now, I don't want to estimate. How can I know that for sure what the middle is? Well, what's the middle of negative 2 and 6? If they're 8 units apart, it would be 4 units from either side. So yeah, I do think that this number right here is 2, because if you go this direction 4, you're at 6. If you go this direction 4, you're at negative 2. So I think that's a true. Is the vertex at 2 comma f of 2? Well, meaning the x coordinate is 2. We know that's true. What does f of 2 mean? That means the y value when x equals 2. That means it's whatever you get when you plug 2 into the equation. Yeah, that's exactly how you would find the vertex. Is the a number less than 0? Well, remember the a number up here in the parabola, doesn't that tell you if the parabola opens up or down? Well, this parabola is opening up, so doesn't that mean a has to be positive? So I'm going to say here, a has to be positive because we know the parabola opens up. And this is saying a is less than 0, a is negative. That's false. Okay. C is less than 0. Well, what does C stand for? Well, remember, C stands for the y-intercept. Well, look, over here, it hits the y-axis right here. I don't know what number it is, but I do know it's negative. So I know that that tells me my C number. This is saying, is C less than 0? Yeah, C is negative. And then this is saying, does f of 1 equal f of 3? That means when x is 1, and this means when x is 3. So an f of means the y value. So does the y value at 1 equal the y value at 3? Well, remember, the axis of symmetry is at 2. So x equals 1 is 1 unit this direction from the axis of symmetry. And 3 would be 1 unit this direction from the axis of symmetry. Well, don't those have to have the same y value? So yes, that's True, because they are equidistant from the axis of symmetry. Okay, so that is the end of all things parabolas.